Hello, very good morning to everyone, and warm welcome to second edition of CeRAI Conversations. So this is a webinar series that we are having we are organizing. We are trying to have this every quarter. So welcome once again, everyone. Without further delay, I'll just introduce Dr. Hemant Pandey, uh, Chief Executive Officer of Center for Responsible AI, IIT Madras. Prior to this, he led ACM India as executive director, uplifting the organization in many ways through innovations and initiatives. In his industry spanning over 25 years, he has held executive technology leadership and CXO roles at Persistent Systems, EZEST, KPIT, and research roles in Siemens Research USA and TCS Research. He received a bachelor's degree from IIT Bombay and has a PhD from Rutgers University in Computer Science. So over to you, Dr. Hemant. Please give us the opening remarks.
Thank you, Gokul. And on behalf of CeRAI, let me welcome all of you, to the second edition of CeRAI Conversations. We did the inaugural session in July, where we talked in detail about AI, responsible AI, and CeRAI, before going into the theme for last time, which was safe AI. This time, the theme is responsible AI in healthcare domain. What I want to do as part of my opening remarks is just introduce the state of affairs of AI, motivate responsible AI, and give you a feel for what we do at the Center for Responsible AI, which is popularly known as CeRAI. And then let's take you directly into responsible AI in healthcare. It's very hard to condense all this in 5 minutes. I've been given 5 minutes, but then the transcript as well as the video of the previous session is available publicly on YouTube, which has the details, as I said. So as Gokul said, the reason we are doing these quarterly webinars is so that you understand the various aspects of responsible AI and how they apply to multiple domains in real life. The last session in July was about a horizontal, which is safety in AI as applied to multiple domains, while today's session is about the healthcare vertical, where multiple aspects of responsibility in AI would be discussed. So let's start with AI. AI is not new. It dates back to Alan Turing's time in 1950s about capability of machines, including whether, as he said, machines can think. So there came a time when AI was thought as omnipotent in 1960s, which was the golden period for AI. And then we had AI winter as the hype died down. And again, in 1980s, the promise was refreshed due to work with Jeffrey Hinton and people, followed by another disappointment because there was overpromise of things. But in late 2010 and then in 2020s, obviously, significant things happened. So prevalence of data from all kinds of sources, I mean, IoT, right? The reduced cost of storage and computing power becoming immensely high, okay? So that definitely gave a huge fillip to AI innovation, research, and so on. So, of course, the extraordinary boost came from LLMs, GenAI, ChatGPT. So AI went into products and AI became products. Okay. So as we can see, right now, AI is everywhere. Okay, I have picked some examples we have here where it's high technology in nuclear fusion, right? Chemical reactions in healthcare also, okay? And there is full slide that I have here, but then again, we are going to hear much more about it in healthcare, okay? So lastly, what I want to say is that it's affecting every field, everybody's life. It's changing the daily life right now. So AI, with this tremendous power in the hands of people at various levels, I mean, individually from personal finance decisions to dating and highest levels of decisions such as defense, drones, aviation, things, grassroots levels like agriculture, healthcare, okay? What we must realize is that with this great power, okay, comes great responsibility. Okay, and that's why, as we know, I mean, AI is here to stay. Uh, Regulations are still being worked on right now. It's affecting jobs. New jobs will come, or already come into play. Okay, but again, to reiterate, all aspects of life are affected. So we do need a multidisciplinary approach to ensure responsible, not just the use, but even the development of AI in a responsible manner. So I am not able to go to the next one. Okay. So these are the aspects of, I'm listing a few of what responsibility in AI would mean. Okay. Fairness. Okay. Introducing or ensuring correct bias. Okay. Bias is not always bad bias. Okay. Also important is explainability. Okay. Can the decisions be explained? And that once you can explain, interpret, and there is transparency, then it leads to trust. So trust cannot be built in. It has to be built up. It has to be built over time. But all these are aspects of people trusting AI. Anyway, so these are the nuances of responsibility. And that brings me to CeRAI. Okay. At CeRAI, we have a very unique proposition. We are focusing on responsible AI. We are a multidisciplinary organization. I mean, as you can see, we started with horizontal last time, but now we're talking about healthcare. We also are very active in introducing, ensuring responsible AI in education, in agriculture, in law, and things like that. And we have active collaboration with industry. I mean, we work closely with the government. And if I were to talk about certain ingredients or some pillars of the proposition of CeRAI, it's technical research. After all, we are a research center. So technical research is our bread and butter, leading to books, reports, publications. Also, we are very active in policy analysis and recommendation. That's where I said that we work with government, in policymakers and things like that. And we do survey reports, we do events. Again, education. This webinar that we're doing is again creating awareness, not just awareness, going beyond awareness, giving you some insights, recent insights, state of the art and things like that. And of course, we have advisory, in some cases, a leadership role with METI. I mean, we are very actively involved in the AI Impact Summit, which is going to happen, the international summit, which is going to happen in February. Anyway, so with that, what I'm going to do is, having given you some flavor for AI, responsible AI, and our host today, which is CeRAI, I would like to now hand over to Gokul so that we can go to the theme of today's session, which is responsible AI in healthcare. Thank you.
Uh, thank you, sir. So yes, so we are moving on to the theme of the day. It's responsible AI in healthcare, which is a very important critical sector, and therefore kind of very important to have all the safety aspects and all kind of design principles to be there for ensuring the safety in this particular healthcare, as it also impacts a lot of lives, right? So we have a couple of very important people with us, like a couple of very important, our own stellar faculty. This is going to be a very interesting conversation between Professor Karthik Raman and Professor Himanshu Sinha. Let me just introduce Professor Karthik Raman first. He's a professor in the Department of Data Science and AI at the Vadhwani School of Data Science and AI at IIT Madras. His research integrates networks, models, and AI to study, design complex biological systems with focus areas including microbiome systems biology, metabolic engineering, and biological big data. He also coordinates Center for Integrative Biology and Systems Medicine, IBSC, and works closely with industry partners on data-driven healthcare and life science applications. At IITM, he teaches courses in programming, algorithm, systems biology. He's also the author of a textbook on computational systems biology. He also contributes a lot to national initiatives on AI education, including curriculums such as AI Summer. And he also advises the Global Office of Global Engagement at IIT Madras. And as recent news, most recently, CBSE appointed Professor Karthik Raman as an expert committee chair to develop AI and computational thinking curriculum for school students from grade 3 onwards. This literally happened a couple of days back. Happy to have you here with us, Professor Karthik. He's hosting this session. So over to you, Karthik sir.
Thanks, Gokul. Really a pleasure to be here. It's been very exciting working at CeRAI and WSI at the intersection of AI, healthcare, and a lot of exciting domains. So today I'm very happy to have with me Professor Himanshu Sinha, who's like a close friend and colleague. I have the pleasure of introducing Himanshu. Himanshu is a professor at the Department of Biotechnology and the Vadhwani School of Data Science and AI. He leads the Systems Genetics Lab, which is a very interdisciplinary group working in population genetics, and is interested in understanding how the information flow from genotype to phenotype is dynamically modulated by genetics, environment, and evolution. He works with yeast populations and to develop transferable knowledge to understand complex human diseases. He coordinates the Center for Integrative Biology and Systems Medicine alongside me, and where we've been looking at very interesting data sets, including very large-scale national projects like Genome India and large international projects like Incentive, where we've been looking at population genetics, vaccine design, maternal and child health, and so on. So Himanshu obtained his PhD from the University of Cambridge in UK, and he's since held research positions at Duke in US and EMBL in Germany before he was also at TAFR, and he's been with us for close to a little over 9 years now at IITM, and very happy to have Himanshu on the call. So Himanshu, maybe some introducing remarks just about your lab or the initiatives you've been doing, and then I'll get into the questioning.
Yeah, thank you, Karthik. Thank you, Gokul, for the and Dr. Hemant for the introduction and for hosting this webinar. So it's been a pleasure to be here because it sort of is like before we delve into healthcare, as Karthik mentioned, I'll just briefly mention that he mentioned few national projects like Genome India, which is the one of the most unique projects that have been done, a multi-institutional project that has been done in India, never done before, funded by Department of Biotechnology, where we have sequenced over 9,500 individuals across 83 ethnicities in India. Given that India is one of the most genetically diverse populations and very unique compared to the Western population, this data set is actually going to help Indian healthcare, because till date we have been sort of working with, let's say, mutations or disease genes that have been identified in Western populations and testing them out whether these genes are actually useful for our population as well. But now we have our own data set, so we can actually start making what is called personalized medicine for Indian population. I think we are very excited about this project. Hopefully we are hopeful that we'll get a very big publication pretty soon. And I think it will be a digital public good that will be available to everybody in India for sure and around the world to be able to sort of utilize it for their own research and developing personalized healthcare for Indian population. So that's one of the things. But I think I'll stop here, Karthik, because that can be a long conversation. But let's go back to the
Sure.
to the
Just
topic of the
a
day.
general note to all the participants, feel free to put in your questions in Q&A. I'll be pitching them to Himanshu. We have some questions that we've and thoughts that we wanted to share, but please do put in your questions, and we'll be happy to take them up as well. So Himanshu, let's first start with what are the key public health problems in India, right? And those that can be potentially solved by AI. And so what are the main problems that plague the country at the moment from across the length and breadth of the country?
So I think see AI, as Hemant said, AI is touching every aspect of human life now. Like, so healthcare is not something that has not been touched, and healthcare has been sort of, we have been sort of trying to figure out how AI can help. And some of the things that I can think of top of my head would be like maternal and child health, and this is one of the focus areas at Vadvani School of Data Science and AI. Because if you think about this, maternal and child health, even though we have made significant progress over the last few decades, we are still have not achieved the sustainable development goals which WHO and UN has set for the various countries. Some of the states have, but there are many states that haven't. So one of the aspects could be, can AI help leapfrog these states that are lagging behind or are aspirational? Can we leapfrog them to achieve a better maternal and child health, which means in reducing maternal mortality rate, reducing infant mortality rate, and reducing neonatal mortality rate? Can we use AI? And there are we during this, hopefully during this conversation, we'll discuss a few use cases and few examples that Vadvani School has been involved in trying to sort of improve these numbers. The other, again, which sort of spans the child health, is malnutrition. And this is something that is an important aspect. We know a large proportion of our population, especially the under 5-year-old children, are malnutrition, and that not only causes higher mortality or higher disease risk to various diseases to these children, but also leads to long-term cognitive disabilities. So the question is, can we identify areas, not individuals, but areas where malnutrition is rampant, and can AI help in developing localized nutritional supplement programs? So like, we can't give, because we have huge amount of ethnic as well as nutritional diversity in India. So can AI help in making localized suggestions? And that's something that we can, or can we help use AI to leverage using portion data sets, and some of the data that the government of India and state governments collect? Can we sort of develop personalized interventions or very localized interventions? So that's one. And obviously, the big elephant in the room is non-communicable diseases. We have seen in recent past, especially after COVID, an increase in cardiovascular disease risk, an increase, a huge, like diabetes capital of the world. India is becoming the diabetes capital of the world. So are there any AI, like, can we develop AI tools that risk stratify individuals early enough so that they can make lifestyle changes before they have to undergo therapeutic interventions, right? Because many of these can be mitigated to a large extent with lifestyle changes. So can we use AI to screen and make sure that these individuals that have been screened as positive do we follow up with them using AI tools and technologies to make sure that the burden, the non-communicable disease burden, reduces? And I think the other place where AI is already playing a major role is cancer research. And we have seen, with the advent of large data sets like in biology, which are multi-omic data sets, be it genomics, transcriptomics, proteomics, and metabolomics, Several foundational models are being developed to identify risk genes that can be used, or genes that are sort of receptive to therapeutic interventions, to be able to sort of, and AI is sort of helping in that, because these are very, very large data sets spanning across tens of thousands of patients. And therefore, I think these are the things that I can think of, Karthik, where AI can actually make a substantial difference.
So, but what do you think are the challenges? Do we have, the appropriate data sets to do this at scale and so on? And, or, it's all buried in different systems and things like that. So can we actually address these data gathering and data quality challenges first up? What do you think those are the most pressing challenges first?
So if you're talking about India, like I'm assuming you're talking about data set challenges in India, because that's what the focus
I think
area
we
for
probably
CeRAI.
have reasonable data sets for, like I think UK has been very good at collecting data compared to most of the countries. But I think in India, you probably have, we've actually instituted lots of programs to collect data. But the challenge is, is it accessible, or is it in some sort of silos and things like that?
Yeah, exactly. So one of the adages that we follow, like as we have been discussing, Karthik, we follow at Vadhwani School, is that for Indian healthcare problems, we need Indian data sets, because nobody has the access to Indian data sets, right? Nobody has collected Indian data sets. And there are several initiatives government has.
Yeah, I think it's extremely surprising, right? That after all these years, we are in 2025 and we are now only publishing our first 10,000 Indian genomes. And that is still the largest. And I still can't sort of fathom that is still the largest data set.
Given that we are the most populous country in the world, right?
Yes, yes.
So I think this, it's good development. I'm happy that we are on that path where we are progressing, where the direction we are taking, the direction that the government funding agencies like DBT or ANRF are taking, or ICMR are taking towards developing Indian data sets. So the challenges mainly are two. I think there are two main challenges. One, as you rightly said, the lack of Indian healthcare data sets. I am sure that there have been several studies that have been done where where good research has been done, where people have collected a lot of data sets, but those data sets are either in silos or on some repository which is not accessible, right? And also what is also there is that there is a difference in the formatting, right? Because when you talk about data has to be in a standardized format. The fact that UK Biobank is such a successful repository is because they have a standardized format where you can interpolate and extrapolate across multiple individuals, across multiple diseases. Here we don't. So for example, we have healthcare management system, we have ABDM, we have National Family Health Surveys, and these are data sets. Some of them are aggregated data sets, some of them are very granularized, but they're not interoperable, right? I cannot take NFHS data and say, okay, let me see whether I can capture the same features or same parameters in ABDM. No, that's not possible. So I think one of the things that we need to build for India specific data sets is like the interoperability, or at least a data lake where all the data sets exist. Then obviously there are, like as with any data set, right, regardless of whatever domain you look at, data quality issues are there. We have had examples where we had tried to develop things and the data was not good in sense that data was there, a huge amount of data was there, but the data was not good. So that's one for sure a challenge.
I don't know. I mean, some of these could be, simple problems such as, training people to collect data correctly, right?
Yeah.
The end users who actually collect and input the data, they may not be very well trained at all. And these sound like, very trivial things, but these are the things that break the back in the end.
So one of the ways that we do when we do prospective studies at Vadhwani School, one of the ways we do is to deploy our own data framework individuals at every site so that they ensure that the whatever data is collected is complete and QC'd at the site, rather than once it comes to us, because once it comes to us, it's already like out of the hand of the site, right? So if a cohort is running in a hospital in Guwahati, I am making sure that the QC is done at Guwahati itself, not at IIT Madras. So I think we need to develop, and there are frameworks, I'm sure, like that's what I'm saying. There are several studies that have done exactly that. It's just that these data sets are not available. And I think one other challenge that is very, very India specific is that India is so diverse, both genetically, and that is what we have sort of understood. We already knew that, but I think the Genome India project just amplified and highlighted that issue.
Yeah, I mean, I wouldn't even get as far as genetics, but as just a country, right? The amount of the access to healthcare and the sort of how good certain districts are versus other districts and so on. There is so much variation, and I would imagine that even when we are collecting data, there is probably a definite bias towards, like, say, urban and so on.
Yes.
So this is probably, I think, as we talk about responsible AI, this might be one of the most important things to address early on. Right. Of course, there are certain other populations could be like highly underrepresented and things like that. So we need to probably, I think Genome India did a great job and sort of showed us what can be done potentially.
Yeah, see, one of the highlights, which is not really sort of given proper credit, is that Genome India data is pretty balanced for both the genders. One of the initial hypothesis was that because we are going to villages, we are going to very, very marginalized societies, we might get a bias where male genome might be more represented than the female genome. But we did a very good job. But unless and until whenever we do data collection or whenever we look at healthcare data, we are not aware of these inherent biases, which could be very, very India specific, especially like urban rural divide. I think that's pretty common across all countries, but it's more so in India, right? Even as you rightly said, even for the states where healthcare systems are pretty robust, there is an urban rural divide. District wise, there is a division, right? Within a state, some of the districts are less on HDI index compared to others. So there is a lot of difference. And obviously, healthcare access is something that, so when I say I'll collect data, I should be aware that I'm collecting data across the whole socioeconomic spectrum. I am aware that at least I'm aware, even if I'm not able to connect, I am aware of the bias. See, that's the other thing, right? We should be aware and be able to realize that this is not the representative data, and learnings from this data may or may not apply to a larger population because the data had an inherent bias, which could be because of multiple reasons, right? So it could be that. So that's
Himanshu, I'm going to ask you a couple of important questions here, right? So how do you think we can fix the current data sets, right? So can we somehow, audit and flag the collection of data, the biases and so on? So is this something that is possible? That is question number one. And the second and most important question is, because we have you on the call, you have to talk us through the things that we are already working on, what you've already done. For instance, I know that this Garbini project that you've been working on has been a sort of eye-opener in various ways towards the need for India-specific responsible AI. And so I want you to just quickly talk about these two things. So I think we have about 10 minutes left. So I want us to quickly focus on.
Yeah. So quickly, if coming to the first question, where what are the solutions, or what are the sort of the I would say paradigms we should keep in mind when we are talking about healthcare data, specifically in India, right? We have to make sure that we are collecting as much as non-identifiable metadata, right? I'm not talking about personal information. I'm saying non-identifiable metadata. We should be aware of age, gender, specifically for diseases which are not gender specific, right? We should, if we can, we should also be aware of community information, because we have seen that there are several communities that are more marginalized than others, right? When we are talking about, let's say I talked about nutrition. Now I should be aware of what kind of nutrition, because if you look at India, Southern Indian populations are rice-based diet, Northern Indian populations are wheat-based diet. Now, if the data doesn't capture that and I make a nutritional advice, and if I'm interested in eating idli and I'm given that no, you have to eat chapatis, that's not going to work. That thing is going to fail. So I need to be and therefore cultural context, right? We should be aware of cultural context, because there are several cultures where there are certain societal norms that we should be aware of. So I think when we are collecting, and I think we do collect that, we keep that in mind, but we should be more rigorous and more sort of deliberate in collecting that information. Whenever possible, we should rely on primary data than aggregate data or secondary data. So while there is a lot of retrospective data that has been collected, but we should be aware of how that retrospective data was collected when we use that for any AI development. We should be aware of what are the cases and controls, because in healthcare, for majority of the time, we need to know what is happening. So for example, if I'm developing a risk stratification model for cardiovascular disease, now if I don't have the controls where there is right now no cardiovascular disease risk, but I don't know whether the heart rate variability ranges between this and this across populations, right, for India, and I only look at the cases where the individuals have been identified with a cardiovascular risk, and I know their heart rate variation data, I would not be able to develop a algorithm, because the data will be completely biased, right? It would only learn from the cases and not know what is the baseline variation for Indian population.
Right.
And that is something that we have been actually discussing a lot. For India, for a lot of things, lot of diseases, and one of the cases that comes to mind is anemia, right? For a lot of diseases, we don't really have the baselines. Baselines meaning, given that Indian population separated from Caucasian population 75,000 years ago, we need to have our own baselines. We need to have our own norms of what is healthy, what is not healthy. Copy pasting norms from Western populations onto India has its advantages. Obviously, you get to know the ballpark sort of range you should be working in. But then when you're categorizing risk and no risk, or high risk and low risk, that is something. Because if you look at anemia, practically a huge proportion of Indian women are moderately anemic. That doesn't always
and even
lead
things
to,
like, BMI and diabetes and so on, right? So, maybe a BMI of 25 should not be the cutoff in India. We have this the thin fat challenge
exactly.
phenotype and so on. So getting back, so please talk us through Garbini.
Yeah,
Right?
I was segueing into that, because see,
Yes.
anemia is one example. So one of the things that and this is sort of is a proof in the pudding kind of example, is that if you look at, I'll just give you a very brief history for the audience, that Garbini project was a project that we got involved in 2018, 19, with our clinical partner, Translational Health Sciences Technology Institute in Faridabad. This was a grant from Gates Foundation, where they brought in clinical and data science partners together. And the project that we had submitted to Gates Foundation was to build a preterm risk stratification model. And that was the model, that was the aim of the project. And what came out of it was a completely new transformational outcome, which sort of was anecdotally available to everybody, but or all the clinicians who are OBGYN doctors or radiologists or people who are involved in ultrasounding pregnancies, but it was something that was not shown. So if you look at preterm is any live birth before 37 weeks of gestation, with 40 weeks being the term, like the complete pregnancy duration. Now, if you are classifying a baby as preterm, and if there is an error in the dating of the fetus, even by a day or two, you could be 36 weeks and 4 days, the baby will be classified as preterm, whereas 37 and 1 day is classified as term. So now you can see the margin of error is a day. So the most surprising part for us was that all the ultrasound machines, be it a GE ultrasound machine or a like Philips ultrasound machine, has an embedded formula which the ultrasound radiologist used to estimate the gestational age of the fetus, measuring various fetal biometry. So in the first trimester, they'll measure CRL, which is crown rump length, or in the second trimester, they'll measure the diameter of the skull, 2 diameters of the skull, or the circumference, abdominal circumference, and the femur length. Right? Using these features, you can actually get a very good estimate of the fetus age. Now that formula, lo and behold, was developed using approximately 300 white Caucasian pregnant women from Texas by a clinician named Hadlock, and this is called a Hadlock formula for first trimester, Hadlock formula for the second and third trimester, and that's embedded in all the machines. What we found while just doing exploratory analysis of Garbhani data set, which is a longitudinal data set, like the women is scanned first, second, third trimester, same woman. So we have like data set for 10,000 pregnant women. What we found that Hadlock actually gives an error of up to 3 weeks. Now, if you are trying to develop a risk model for preterm with a 3-week error as a noise, your classification will not happen accurately at all. And which was what we are saying. So what we did was we said, okay, let us develop using this Garbhani data. Can we develop a gestational model for India? So we developed the first formula we developed is called Garbhani GA1, which is the first trimester formula. And obviously, not surprisingly, Garbhani GA1 performed similarly to the Hadlock formula for the first trimester, because in the first trimester, majority of the development is primarily independent to the maternal nutrition, because it's mainly organogenesis, like the embryo is just developing. It's not growing, it's developing. So there is a difference between developing and growing, like it's embryology happening. Second trimester onwards, maternal nutrition or maternal environment starts playing a role. Now comes very, very specific problem for India, right? Which is only found in India, nowhere else, not even any other Southeast Asian country, right? Is that according to National Family Health Survey, approximately 40 to 50% of pregnant women do not come for a scan in the first trimester. They'll come for the first scan in the second trimester. Very unique to India. Nobody is going to touch up. Nobody would even know about this issue outside India. So what happens is that when these women come, these 50% women come in the second trimester first time for their ultrasound scans, the ultrasonographer is using Hadlock formula on a 18 to 20 week old fetus to determine the age. The first trimester dating is considered gold standard by like OBGYN societies across the world. So they have not got that dating. So what they have got a dating at second trimester first time. And at that point, Hadlock already has 3-week error. So what we developed was another formula called Garbhani GA2. GA stands for gestational age 2, which reduced that error of like a median error of 1 week to less than a day.
And this
that was
underlines how we need to solve these problems in an India-centric fashion,
India
right?
problems
and
for India,
without the data that was originally collected in the Garbhani project, right? So thanks to that massive DBT project which collected this huge amount of data, I think this was possible. So I think we have to probably start with such focused data collection and then tap into all these repositories and our data collection systems and so on.
So just as a small aspect, like to conclude, like for example, even when we developed Garbhani GA2, we know, and this is where responsible AI framework comes into picture, right? One should be aware of the limitations of any AI algorithm that you have developed, right? The AI Garbhani GA2 formula was validated at 2 sites, in Faridabad and in Vellore. What we are currently doing is doing a validation pan-India, because we want to ensure that this formula works for all pregnant women across whole of India rather than just being too site specific or very, very site specific. So unless and until you are aware of that and you say, oh, I have developed this formula, let me just put it out in public, it will fail. And that's what happens for a large number of AI algorithms that are not fully validated in real world data sets. So one is, as you rightly said, have a very focused data collection efforts and then do real world testing, because both of them are absolutely essential for making sure that the algorithms are grounded in data and are robust. Yeah, please. Yeah, go ahead.
So last question from my side, and then we can quickly look at some of the Q&A, and some of them you can even type your answer right after our chat. We have just 2 minutes to go. So how can we ensure that AI for healthcare is not harmful, right? I think this is one of the challenges, because it's there's always a worry that these AI systems are not. We are all, as somebody remarked, right? We are all building the airplane and flying it concurrently, as you see with most of these chat GPT and so on. And with respect to AI in healthcare too, right? Is there a danger of early adoption versus how do we ensure it's not harmful?
So as I like in the last question answer that I said, we need to have real world validations, right? A small scale pilot doesn't help, because small scale pilots,
especially in India,
especially in India, right, doesn't help because we know for sure there would be a bias, right? That's one aspect. Second aspect is, given our linguistic and cultural diversity and given our cultural context, right? Many of the algorithms or many of the ideas that we have sort of carried forward may or may not apply everywhere, right? So I think before even deploying, we need a robust validation mechanism and a framework, especially for India. If I develop something for Tamil Nadu, I am 100% sure it will not fly at all in any northern state. Not because they're about not just including the healthcare systems diversity, but because of the cultural context. And nutrition was one example, right? So the other thing is, I think one of the ways we need to, and this is something CeRAI is doing very progressively, is to sort of make clinicians aware of how AI can help, right? If you ask clinicians, they will have a lot of sort of problem statements that AI should be helping in. But in my view, and I think you also would agree, that AI tools and technologies should be assistive devices rather than as a replacement device, right? So if I can build an AI algorithm which allows the doctor to screen 100 patients in a day more efficiently by categorizing normals as one group and then high risk as another group, a simple red-green kind of a thing, that will reduce the harm. Why? Because normals are progressing normally. Like I'm not talking about, let's say, pregnancy. Normal pregnancies are happening normally. Doctors can spend more quality time with high risk patients, high risk women, right? So that they can mitigate their issues more carefully. So I think there are, and it's an evolving technology. We will have to sort of learn along the way. Chat GPT, you said rightly, it is a tool that is, people are using it. Like even we use it very often. Like we can upload our reports and it will give a very cogent kind of a output. Whether that cogent output is medically correct, authentic or not is a separate issue. But for a layman, it would look very nice. So I think there are issues that we should be aware of, but I think centers like CeRAI should develop, like we should have a policy framework for AI algorithm validation and deployment, because and as with any AI tool, as more and more data you get, the algorithms become either more robust or they break down, right? So we should be also aware of that version 1, 2, 3, 4, that's going to be more more sort of useful or not. So that is something an ongoing process. And I think I'll stop here because this is a conversation that can have another, that could be a general
Yes.
CeRAI conversation that we can maybe Gokul and Hemant can organize later on.
Yeah. So sounds good. So I think there is, I mean, I've answered most of the questions on the chat. You may want to just add an answer to that maybe. So since we are running short of time, I think it's probably good to hand it over back to Gokul. And Gokul, you want to take over?
Yes, sir. So thank you so much. That was a great conversation indeed, and I do agree that this can go on further, and we will take that into consideration to have a dedicated conversation episode for this topic. Right. So thank you very much, Professor Karthik and Professor Himanshu.
Thanks, Himanshu. Thanks, Gokul.
Yeah. So just give me a moment. There you go. Yeah. So next, we have our own Dr. Soumya Sundaram. So Dr. Soumya is a research scientist at Center for Responsible AI. She has recently joined us. She has experience working in the field of AI for healthcare in the last 5 years. And she received her PhD from IIT Madras and recently completed her postdoc at Stanford School of Medicine. Welcome, Soumya, and over to you.
Thanks, Gokul. Just share my screen. Sorry. Yeah, is my screen visible?
Yes, go ahead.
Okay, yes. So, hello everyone. I'm going to talk about responsible AI in healthcare as the theme, and specifically, I'm going to talk about one particular aspect of it. So, I'm going to start off with an example of an article, which is named, as you can see, Medicine and the Computer, the Promise and Problems of Change. Now, we heard even in the beginning how AI has been around since forever. And I was curious when this article came out. And it actually came out in 1970 in the reputed medical journal, the New England Journal of Medicine. And what I found surprising is that most of the issues mentioned are actually applicable in this LLM era itself. So, one advantage of having so much influence of AI in healthcare is we can actually learn from the deployments of AI in healthcare. So we can start off with Mycene, a rule-based expert system, which talked about how you can figure out whether you need to administer a gram-positive or a gram-negative antibiotic based on the input given. Much later, we have IBM Watson Health that focused on oncology. And more recently, we have COVID detection tools. So while there has been so much of research of AI in healthcare, there have been consistent issues in deployment. And I'll be talking about one particular aspect of it, which is stakeholder engagement. So at CeRAI, we work with multiple stakeholders, as Dr. Hemant mentioned, and stakeholder engagement is especially important to build responsible AI applications. So, who are the stakeholders in AI for healthcare? When we think of that, we think of two broad sets of folks. We think of AI clinicians. So, when we talk about stakeholders in AI for healthcare, we are not going to get magical solutions by putting AI and developers and clinicians together in a room for one sitting. So, it's a much more continuous process that's more multi pronged. So, who can we think are the stakeholders in AI for healthcare? So, of course, I'll start off with the clinicians and the AI developers. But we also have the hospital administration, the environment in which this AI algorithm is going to sit, how it's going to be deployed, How are we going to make it safe? Maybe with the human in the loop. Who's going to take accountability for that human in the loop? We need policy experts to decide how this conversation is going to happen, how safe it is, and so on. We also have clinical guidelines that differ, as we just saw in the conversation, how diverse Indian needs are and how clinical guidelines might differ based on different aspects of healthcare. We also have researchers and academic institutions to provide evaluation or even diagnostic algorithms and kind of you need research both within the ecosystem and outside it to kind of make it more robust. You also have insurance and healthcare allied institutions. So in the US, you'd have something like a skilled nursing facility. In India, we might think of lab technicians who work outside a hospital. So we have a lot of allied institutions that also interact with healthcare. And if the healthcare setup is using AI, that might have downstream impacts as well. Recently, there's also talk of including patient perspectives in AI policy, where we talk about how patients would like their data to be used, how to frame consent forms such that you're not absent-mindedly ticking a box, for example, and so on. So it comes into policy, but it's also a perspective that's often missed in AI for healthcare. So if we know these are the various stakeholders and we just need to talk to them, then that's great. But it is a very challenging perspective. So we have competing needs. Maybe the AI developers want as much data as they can. Maybe the patients and the clinicians want to be more careful. So the idea is the needs can't exist in silos and there should be communication so that we build the best model that would help everyone. There's also overwhelming requirement elicitation from diverse stakeholders. It need not even be from a clinician and an AI person perspective. It could even be something like someone who's developing AI algorithms might use Python, and someone who's a biomedical informatician may use R. How do we share code? What are the conversations we have? And there's also a lack of continuous feedback. So we need feedback in the problem development stage, in the design stage, in the evaluation stage, and in the deployment stage. And that's what is going to build a model that's robust. We also have difficulties integrating these AI systems into the existing clinical workflows. How do we position the human in the loop at deployment? How does it integrate, say, with insurance systems and so on? So all of these complex handshakes also lead to erosion of trust among clinicians and patients, especially if AI is not explainable, which is why a role like CeRAI is very important so that we can make it more transparent. So the need of the hour is more robust multi-stakeholder design. And I'm just putting out few questions, which is how do we have a shared vocabulary to define the problem? And how do we improve the design such that automation bias is reduced, or rather maybe trust is increased? And these are just questions that are part of the problem. There are many questions that come up when we design such algorithms. So I'm going to talk about stakeholder engagement in practice. As Gokul mentioned, I've just joined CeRAI, so I will be banking on experience I've had before. And I'll be talking about 3 case studies and the lessons I learned in stakeholder engagement. So there are 3 projects. One is known as Backdata. The second is a cochlear implant project. And the third is a genetic epilepsy project. So I'll get started with Backdata. So Backdata is about dental implants and the bacteria that gets deposited on teeth after implantation. So this project idea was that we want to fight the bacterial development on implants. So what the problem is, sometimes the bacteria that develops on implants is antibiotic resistant, and it might even lead to loss of a tooth. So ideally, we want to predict when these implants are going to get infected, and when we want to schedule maybe an analysis or a examination, or maybe even predict that this implant needs to be replaced. And talking of personalized medicine, we've often found that there are few biomarkers that suggest that your implant need to be replaced faster. So how do we predict who needs the implant replaced and what time? And we went in with this as a classification task. So this was a multi-stakeholder project. This was done in Germany at Hanover. I was at Leibniz University, Hanover, and the multiple stakeholders were dentists, specific infection researchers, biomedical researchers, ML and NLP researchers. And the idea is that we have these multiple centers, even located at very different places in the city. And we want to come together and work together and figure out how to develop this classification model. So we're working on the problem definition. From the get-go, all the AI folks were like, do you have enough data? Do you think it's representative enough? And the answer we got is, of course, there's so much of data, there's TBs of data, and we've also classified it really well. We have 3 specific disease explanations, and no, they name them as the mucositis, peri-implantitis, and healthy. I'll talk a bit about what these conditions are, but basically we had 3 diagnoses, and we had to describe what caused these conditions. So we started examining the data, and what we found was that, yes, we did have 1 TB of data, but they were only for 100 patients. So then we had to explain statistically that big data is not that the size of the data is big, but the features need to be in reasonable size for the samples, and we gave some heuristics for them to work. And that led to an innovative feature reduction. And I am not sure of the biological aspect of it, how the genetic information became enzyme counts, but for us, there were much less features to deal with, but still difficult to make reasonable classifications. We did some feature selection, tried to do something meaningful with it, and we got good accuracy, and we were happy. We saw that the samples were representative across the classes, and we went back with that. Unfortunately, that was not a good model, because every feature at inference time is prohibitively expensive to apply. And when we think of machine learning tasks, we think, okay, I have this complex function of 10 input features, and that's good for my classification. But it turns out that sometimes computing this is quite expensive. And the accuracy, though high, was basically predicting healthy and peri-implantitis, which is basically saying the damage is done. Whereas what we really want to predict is mucositis, which is the onset of damage. So this is a healthy implant, and mucositis is like it's getting more inflamed, and peri-implantitis is, yes, the bacteria has set in, you're infected, and so on. So we came together, and we published a paper on this after that, after we got these things sorted out. So what are the lessons we learned from this? First is that there were a lot of assumptions on both sides that led to a lot of back and forth. And one personal observation was that it started during the pandemic, and we saw massive improvement once we started meeting in person and could brainstorm these ideas. So I'm moving to the next project, which is a cochlear implant project. And a cochlear implant is basically an invasive surgery where you place an implant right in your inner ear to improve hearing outcomes. Now, the interesting thing is, if it works, your hearing improves dramatically, but there's also a chance that it may not work. So, when you have such an invasive surgery, it completely depends on the clinical skill and the experience of the surgeon and the clinicians on coming up with whether the cochlear implant would be successful or not. So, again, in the context of personalized medicine, we were researching whether the implant helps in whether the surgery is successful in improving the hearing ability. So again, this was a multi-stakeholder project with the hearing center and the medical school. We have the AI researchers, the clinicians, surgeons, and also geneticists. It was a multi-omic data set. And this time we worked more thorough questions on the data. We got the distribution of the data, how many patients, how many features, how many classes. So there were just 2 classes, whether you need surgery or not. And they were also very vocal that they need more explainability. So we thought we'd get started off with the simplest model that could offer some form of explainability and went ahead with the decision tree. And they couldn't get past 60% accuracy. So we wondered, for a binary class that's just slightly better than guessing, is this even useful? But the clinicians and the surgeons were very excited because the decision tree corroborated with well-known clinical correlations. Importantly, that the cochlear implant is extremely successful for children less than 10 years. So that validated we were on the right track and the statistics was holding up. It led to a deeper analysis and we tried to establish statistical causality. And it's still a study that's happening. We even found that there was a correlation with the manufacturer of the implant. So we think implant design itself had some effect. We switched it up a bit. We tried to make it a regression problem instead of a classification problem, trying to predict how much difference in hearing ability actually happens. And this led to a review in causality. So what were some of the stakeholder lessons we had? We were very clear about the input this time, but the output, we just asked if feature selection was necessary. And there was not much consensus in the beginning what the output should be. But after seeing the decision tree, we started working towards how the output could be. And I think this often happens in medical settings that we have an exploratory phase where even the problem definition is quite exploratory. And once again, a personal observation was we visited the hearing center, we visited the working pipeline of how the clinicians and the surgeons interact, and that actually helped us formulate the problem better. So with these 2 projects, I'm switching to my latest project at Stanford. And this was working with a neurologist and a healthcare team. And it was, even within neurology, it was a very specific subfield known as genetic epilepsy. And in this niche field, doctors have to be on their toes, being abreast of the latest literature because research happens very fast and changes also happen very fast. So a lookup or a reference tool was desperately required, which is like they want to be able to key in some symptoms and see what are the potential diagnoses, like a differential diagnosis. And this particular task does not have a good performance with LLMs, and we're trying to bring a trustworthy equivalent. So it's still under review. And the multiple stakeholders were again clinicians, healthcare specialists in this case, and the AI folks. So this time the problem definition was really well spelled out. And what really helped, I felt, in this was that By this point, the healthcare setup had already some exposure to the AI framework and the requirements, and the team on the other side had some experience with how the medical um, environment worked. So, in order to make it trustworthy, we wanted to ground it, and we asked for a knowledge base that could verify these results. And we chose one particular database that's used by the professionals in the field. So we discussed the input and output in detail, and it was a simple lookup task. You have the symptoms in text, and the algorithm would have a list of symptoms and diagnosis from the knowledge base OMIM. And this, honestly, to me, looked very straightforward. You use an embedding models, do something like a RAG, get the closest symptom, and report the diagnosis. We decided to go ahead with this. But it didn't work at all. It's not like it worked poorly, but it just absolutely didn't work. Because just like we heard in the conversation previously, data collection and the format of data collection is so important that we then looked closely into OMIM and found out that the symptoms were extremely similar and too many. There were 100 ways a seizure was mentioned, and it was very difficult to pinpoint what diagnosis matches. And there were other assumptions as well. For example, we are looking at genetic epilepsy, but OMIM has diagnosis, I think, for a lot more conditions. Even after we took the subset of only genetic epilepsy diagnosis, there were doctors who were inputting symptoms other than seizure, because they're dealing with epilepsy and seizure is always there. So there were kind of these engineering details, but even apart from that, the metadata stored was so bad. And that's also because there's a lot of free text that's being used. So we then came up with a clustering plus retrieval approach that improved the performance. And now we are looking at a contrastive approach. So there was some key advantages of this design. One is that retrieval is reproducible. Problem with LLMs is often that because it is generation, we get different answers every time. So the trust erodes, even if they may be correct. Say we ask top 5, and always your correct diagnosis comes in the top 5. But the non-reproducibility of it does have its own issues. And that's also a reason why we chose not to go into the fine-tuning kind of method. And the second was the OMIM database just dramatically increased trust among the practitioners. So what were the lessons? One thing I observed was that we had a lot of pictures, either a UI or a graph, and that helped bring about some understanding and dispelling our assumptions. And we asked very stupid questions on both sides that led to a lot of constant communication. For example, I learned that absence seizure is not absence of a seizure, it's a type of seizure. And my collaborators learned that there are generation models and embedding models, and embedding models help with retrieval. Again, regularly met in person. So I gave these 3 case studies, and I want to kind of collate some of the lessons I learned. One is the definition of the goals, the parameters, input and output. It might look quite simple, but when we destruct the assumptions around it, becomes an involved task. And we observe the stakeholders in their workplace, and we invest in UI building, which is now quite easy with LLMs, and communicate. At CeRAI, I've started being involved in 3 projects, which also include diverse stakeholders, policy, pharma, technical, clinical, and so on. So hopefully in the next conversations, I'd have more stories from these projects to tell. So some closing comments. The deployment of AI in healthcare requires more work and research. Even at Stanford Medicine, which is one of the largest departments in the university, the deployment rate is quite low compared to the volume of research that's happening. And for AI practitioners, the exposure to the work environments is very useful. And interestingly, the challenges and deployment lead to very theoretical, interesting research problems to work on. And for clinicians, the explanations give, again, a unique scope to work on interesting problems. And finally, the stakeholder management itself, it's considered an art, but it's also a science. We need more research on how this conversation needs to take place. There are some publications coming up. I'm also part of a study where we are contributing our experiences to a repository, and qualitative studies are happening. I'd like to end with this, that if AI can diagnose patients, what are doctors for? It's an article that came out in the New Yorker, and it echoes a sentiment I heard in a medical conference recently, which said that uh, if I were to die due to a medical error, I would rather it be done by a human than an algorithm. So just some food for thought. And yeah, thank you.
Yeah, thank you so much, Soumya. So people can key in their questions in the Q&A box, and it will be taken after our last talk for the day. So we have Mr. Manu Dev from Roche. Roche is one of the consortium members at CeRAI. And Manu Dev is a global head of IVD Analytics products domain at RIS Roche, where he drives the success of digital healthcare products powered by data and analytics in the diagnostic sector. With nearly 20 years of experience in R&D for digital products, Manu is an R&D leader in steering data and insights based software product teams to commercial success. He holds a background in computer science and a master's in business administration with a focus on AI and machine learning. Manu leads the in vitro diagnostic analytics domain chapter at Roche and is passionate about leveraging AI, machine learning, and empowered teams to make a positive impact on global healthcare. He has a significant amount of expertise in technology, strategy, product management, and the development of SaaS analytics applications for healthcare diagnostics labs, operational efficiency. Mr. Manu Dev, over to you. Welcome.
Thank you. Thank you, everyone. So let me try to share my screen, and I'll go from there. Okay. All right. I hope you can see my screen.
Yes.
All right.
Please go ahead.
Perfect. Thank you for the great introduction. So my background is from around digital applications in the diagnostics part of the healthcare. So today I'd like to talk about how we navigate the opportunities and challenges in AI in healthcare in the context of responsible AI. So first of all, why is AI in healthcare important, and what are these opportunities and challenges? So it is important and it is urgent because AI and ML is going through this incredible accelerated adoption in a lot of the cutting edge treatments and diagnostics and various part of patient healthcare journey management. And an incredible amount of data is being generated from regular diagnostics, treatments, EMRs, variables. And a lot of the companies are already using AI and machine learning in some form or the other. So there are surveys from a couple of years back when it was 94%. The scenario would be today even more complete. And the global healthcare market is growing. And with that, the global healthcare AI market is also going by leaps and bounds. So estimate is 188 billion by the next 5 years, which might also be conservative. So while all of these things are happening, for us to have this incredible piece of technology with AI and machine learning, we have now an opportunity to really apply it responsibly throughout the industry. So that's what going to be the topic of my talk. So I'll start with basically how does the diagnostic landscape evolves. Um, so traditionally, as you know, laboratory diagnostics have been relied on human expertise. So you have people going the laboratories, pipetting out samples, putting in separate instruments, and then visual inspection of samples. And that has worked. It's a testament to the skills of the incredible professionals we have in the laboratories that we get reliable information and data points for physicians and clinicians all over the world to make these important decisions about patient treatment. But over the course of time, there are several factors which are impacting this traditional setup. So first, there is a skill shortage in the diagnostic laboratories. There is an increasing demand on the other hand side for the diagnostic services because globally many countries are facing the challenges of aging population, increasing burden of chronic diseases, and also from the overall lifestyle perspective, the engagement with the world population is turning more towards wellness instead of just being, acute episodic care. We now look at preventive medicine, we look at screening, we look at health management. All of this kind of bring a lot more need for diagnostics services. And the volume of the demand is increasing while we still have this skill shortage in the diagnostic laboratories. On top of that, as the diagnostic demand increases across the globe, there is a trend of consolidation in the diagnostic industry. So you'll see not this one-room diagnostic laboratories, which we are familiar in India in many cases, but slowly these are now becoming this centralized laboratories with collection centers and this huge laboratory chains spread across the country. And this is a trend across the globe, whether they are in the countries where the healthcare system is managed supported by the government, or in countries like ours where a large part of it is out of pocket, the trend is pretty much the same. So in this context, the one of the things which has worked so far is automation. So there are now in a lot of diagnostic laboratories, huge automated machines which do a lot of things in an automated way. But increasingly, now we see a lot of AI and machine learning tools, which can help with screening, which can help with a lot of quick sorting and things like that. So here, the landscape is evolving toward AI as a co-pilot, not to replace people in the labs, but to kind of augment their skills and freeing them up for more complex tasks, for thinking analysis, and taking care of a lot of the routine sample handling and routine tasks in the laboratory. So that's where the diagnostic industry, the diagnostic landscape is evolving towards. Now, with this, we have a lot of opportunities for AI in diagnostic laboratories. So we have things like when the sample goes to laboratories, looking at pre-analytic error detection. So wrong blood in tube, wrong tube, hemolysis, and other kind of quality issues with the sample. We have ways of looking at this quality and kind of giving early warning. Oh, your sample is compromised. We need to probably do a reorder. The instrument error detections, avoiding downtimes, doing proactive maintenance, these kind of things are now, a lot of these things are now being looked at from a perspective of, can we do it with database approach? Can we do it with machine learning? Can we use AI in kind of predicting and scheduling a lot of these things? Similarly for test reporting, so clinical result interpretation in the labs, medical validation by the clinicians, all of these things are now using a lot of the AI generated insights. workflow control, so how a sample moves throughout the lab, how so those kind of workflow operational efficiency kind of optimizations, as well as the laboratory operations in general in terms of supply chain and demand forecasting and staffing and things like that. Also in a lot of cases where we have this huge automated laboratories where we have this tracks and automated samples. If you look at how these laboratories are set up and how they are kind of respond to like seasonal growth in the demand, they look at a lot of planning in terms of how the sample will be routed, where the instruments would be placed, using a lot of the digital twins for planning for the laboratory setup. And then we have on the other hand side where the diagnostic information is now used inside the hospitals. So using the data from the diagnostics, prediction of events, looking at kind of doing a diagnosis, doing screening, doing prognosis, doing risk predictions, providing treatment advice, providing right kind of test selection and looking at issues across the diagnostic and the clinician side of the story. These are a lot of the areas where we have now in the industry, in various places, in various forms, AI and machine learning either being used as a day-to-day operation, or really kind of, in some cases, they now form the main backbone of these kind of operations. So that's the kind of a look at where from a opportunity perspective in diagnostics and healthcare, where we are applying using AI. And there are several use cases. So you have seen a lot of intelligent image analysis. You have using AI for non-cancerous diseases, a lot of hematology-related AI use cases. You have a bunch of pathology-related AI use cases where which helps the pathologist to really augment their skill and expertise. And these are in the laboratory and in the diagnostic space and the clinician space. But also, you know already, like AI is now being used extensively in drug discovery. They are being used in patient monitoring, where you have this wearable devices kind of providing a huge stream of continuous data. You have predictive analytics in terms of patient care, where you stratify the risk, you kind of manage the patient journey based on the predictive analytics which is coming out of these AI predictions. And you have a bunch of healthcare operations which are targeted towards reducing the administrative burden for healthcare professionals, things like setting up patient scheduling, resource management. So the sense I want to give you is like AI is really pervasive in the healthcare industry. It's huge. We have more and more predictive and proactive insights, which are being driven by historic analysis, driven by risk forecasting, which are driving this personalized treatment. They are driving the targeted intervention. They are looking at the workflows. So this is here and now, and the industry is really adopting the AI and machine learning approaches across the spectrum. So these are all the opportunities, but they also come with the challenges. And we already talked about a lot of them in the previous talks. So one is privacy and security, and other is dealing with the impacts of bias in training data. Professor Himanshu talked about the radiology example with the fetuses. These are a couple of examples. There are many such in the industry. And then trust and explainability, which we talked about in the last talk, about building the trust in AI-driven decisions among the doctors and patients, whether a decision which could lead to a life or death or a serious health outcome for a patient. Do we have enough trust with the doctors to use these tools? And do we have enough trust with the patients to kind of accept these kind of treatments? These are the few main challenges that we have in AI in healthcare. And there have been a lot of studies. When we talk about applying this to an actual hospital and an actual laboratory, we get a lot of questions, and not all of the professionals, like think of a physician or a lab director who has done things in a certain way for last 40 years. Um, um, they're not always, they have a lot of questions on how they can adopt AI, how do they um, get the trust. As somebody mentioned a very great line in the previous talks, that trust is grown, developed, and not built. So some of the concerns are around who's responsible for the ethics. How does AI treat with the AI ethics deal with morality and the society and humans? Who should be trained? Who should be accountable? And taking the really technical and cold, impersonal aspect of AI and applying it to human beings, people in who are sick and are under serious mental stress and anxiety. So these are a lot of questions that that are really important when we talk about ethics and responsible AI in healthcare. And I'll also give an example of how the craze that we have and the blind reliance we have in a lot of places with generative AI is not helping the situation. So this is a anecdote. So this is also published in a essay about ChatGPT making things up. It started with a researcher talking about ethical debates surrounding pelvic exams of women and the anesthesia. And as in many cases, ChatGPT gave a list of references, all of which were fake, and the links did not work. But this one was personal because so Katrina is there was a paper quoted here, pelvic examination and anesthesia by Katrina Banstad. And Katrina is head of bioethics in Roche, and she brought this up like, so I'm being quoted. So industry experts are being quoted with the name of the publication and link. It really does not help in situations like healthcare, even for research, even more so for actually patient treatments, where these kind of examples set really cause anxiety in how much we can trust AI. So at Roche, how are we approaching this problem? So Roche has published principles for responsible AI ethics. So we did extensive benchmarking across the industry with pharma, diagnostics, medical devices, and biotech industry. As well, we consulted a lot of global organizations, academics, governments, non-government. And based on that, we have Roche AI ethics principles. And this is public. You can Google Roche AI ethics principles. The link is here. I'll try to see if I can share this. And they lay down the 11 principles that we talk about. So maximizing the benefit of AI, providing transparency, having humans in control where they can override the decisions made by AI, and the autonomy can be controlled, and having accountability of monitoring and feedback and governance. They also talk about sustainability. So when we think about the future impact of AI systems on our global society, and also fairness and minimization of bias. So these are the principles now published by Roche, which we try to follow in all of the decisions, whether it is software, whether it is using AI for operational efficiency, whether using AI for clinical decisions, supporting clinical decisions. So these are principles that we follow in the industry. Apart from the AI ethics principles. We also have Roche data ethics principles. They also kind of go through the data that is used for AI. So the AI ethics principle talk about how do we apply AI responsibly in healthcare, and data ethics talks about the data that we collect and use. They should be fair, non-discriminatory, transparent. The quality should be public. The privacy, security, sustainability, all of that, kind of the data sets that go into building and training and being used in these AI systems. So those are the couple of principles. All of this is public. Hope you can go and access it. And so again, we talked about. So with that, I have one more slide for which is kind of maybe a call to actions for all of us. So the principles are great. They can form this guidance on how we make these decisions. There is need of taking these principles and applying it in actual life, and the decisions that we take, the things that we build, and the products that we put into the market, and how they impact patients and physicians. So there's always a race between the technology and how wisely we can use it. And this is where I think responsible AI really comes into picture. How we use ethics, how we use the responsible part of applying these technologies in the industry. So the call to action from my side that we are following, and I hope more and more of the industry and academia and all of the professionals working in this field follow, is make ethics part of your design language. So while we talk about specificity and efficacy and all of that, ethics should also be part of our language. And it is not about, so in the software field and a lot of this legal and regulatory are usually where the AI ethics and responsible AI discussions kind of center around, but it has to involve people beyond the legal. They have to have ethicists, socialists, domain experts in determining what is ethical and what is responsible. And then it cannot be one-time submission. We go through FDA, we get CE mark, or we get government approval to launch a particular product, a particular system in the market. And that's a one-time thing. It has to be a system of continuous reflection and how we evolve these things, how we change them. And finally, the decision that we take, whether it is data collection or the models, should reflect a conscious and moral choice. And while there is no fixed formula of what these decisions are, like think, for example, an incurable disease. Maybe you have an AI model which can predict the onset of this disease 1 year earlier than what is the state of the art today. The conscious and moral choice should be, do you want to add one more year of trauma and anxiety to that patient? And I'm not saying the right and wrong, but these kind of choices and conscious decisions should be part of the system that we build. And I see in the industry, several healthcare firms already applying it. For the few examples I saw where major healthcare firm has this AI ethics review board, which means monthly, to evaluate what are these new models, will that impact the trust, how will, are there bias, has there been work done to really surface the bias that exists, what is going to be societal impact. These are discussed along with the performance metrics. So this is where I think it is very important for us to incorporate the responsible AI in the healthcare industry. So that's it from my side. I hope you found it useful. Back to you, Gokul.
Yeah, thank you so much. Thank you so much, sir. So I think we have reached a point where people can still key in questions, by the way. We have a few more minutes left on the clock. So I see that, okay. Oh, someone had raised a hand, but if you don't want to speak, you can still key in the question in the Q&A tab. Okay, so I just wanted to say that it's very interesting, to see all initiatives by Roche, and the amount of things that are out there in public is also very impressive. So, and your call to action is very valid, right? So, and I believe that we can also collaborate a lot. We are already in the path of it, but the call to action just calls out to the larger public here who can be part of this initiative in some way or the other, right? So, okay. Yeah, we have one person raising hand. I'm just going to allow the person to speak. So, Kumar Singh, you can unmute and speak.
Hello. Hello. Hello.
Yes, we can hear you.
Yeah, thank you. Since you're using any mathematical model to formulate your problem statement, so what are the biases that you put in the model to make it more personalized for patient care? And how do you make sure that the patient receives the right treatment based on how mathematically that model is?
Sure. Thank you. So, any of the speakers want to take a dig, or I can give a generic answer, but Soumya or Manu, you want to?
I think you can go ahead, and then I can follow up if I need to add anything.
Sure. So it's more like, so the answer is very, very generic, right? So the question is way more specific, how to mathematically measure whether someone received a treatment. But I think the AI is not actually going to go and deliver the treatment, rather provide maybe an assistance or recommendation to the medical personnel, right? So the key lies in the evaluation strategy that you have to ensure whether everyone is fairly being treated by the system, right? So treating in the sense the AI's consideration for all the groups of users. So you are actually going to go and measure whether your accuracy or the performances are fair across the categories of users. So that's the extent of AI being part of the system. I think the rest is kind of up to the up to the system, to the healthcare system to take a call. Right. So Soumya, you have anything to add? Yeah.
Not much. I think just in general, mathematically, modeling one patient, coming to that level of detail is also quite hard. That we try to come to that level by a population-based study is my understanding. I think I need people with more expertise in that to talk about the theoretical modeling.
Sure. Thank you.
Thank you.
Yeah. So we see a couple of questions in the Q&A tab. So yeah, you can check our project's information for sure, and do reach out to us in case of any queries. But other than that, there is a question. So do any of the speakers want to take this up? Could it be possible to expand the current UHI capabilities to collect India-specific data for healthcare? And there is one more. People regarding AI implementation always talks tertiary healthcare setup. so I can see that the answers are being attended to, the questions are being attended to. So we have also taken note of the questions that came up. So like last year, we will try to address any questions that have not gone attended. So with that, I think I will thank all the speakers and all the audience who attended the event, especially to the ones who asked questions. So thank you so much. So thank you once again. And we do have an upcoming CeRAI Conversations. We will have it in the next quarter. So the dates will be announced. So please do stay tuned. Follow us on social media to get to know our updates. So thank you once again. And a big thank you to the people who worked behind the screens also to make the event possible. Thank you. Thank you, everyone.